The next thing that we really want to look pretty closely at is equivalent expressions and equations. Expressions, remember, is just one side of an equation. The equation puts two things together when an equal sign in the middle. Equations equal. And specifically, we're going to be looking at addition and subtraction of integers. So the first thing we're going to do is look at expressions, because those are going to be part of our equations. Same but different method. And I know you're looking at this first one going, what is that, Mrs. De Silva? Because it's simply 10 plus 3. But there is a way to convert that to end up with the same thing. So first of all, we can always just, because it's addition, we can always just swap the positions of things. So what I'm talking about here, of course, is 10 plus 3 would always be the same as 3 plus 10. That's using that commutative property that you should be familiar with. If not, just remind yourself of it. Commutative property means we can switch the places when we're adding. That does not work the same when we're doing subtraction, so just hold on to your seats, folks, because we're going to be getting there soon. Anyway, the other thing we want to do is we know when we have the opposite of something, it goes, in the other direction and gets us to 0. But the opposite and then the opposite again gets us right back where we started. So when we think about that, doing the opposite and then doing the opposite again, getting it back to where we started. So if we, for instance, take this 3 plus 10, we keep the 3 the same, and then we do the opposite of adding, which is subtracting, and then the opposite again would be to change this positive 10 to negative 10. That is also going to be equivalent or mean the same thing. Because think about this, folks. Again, we get to do the cha-cha-cha. I know it's so fun. Anyway, if we do stay, change, change, cha-cha-cha, look at that, we're right back at the same. So you can see how these mean the same thing. So if we take that beginning one down here, where we had 10 plus 3, we keep the 10, and then we do the opposite and then the opposite. We're going to subtract and then take positive 3 and make it a negative 3. That means the same thing. And if we wanted to prove it, again, we would do our cha-cha-cha, stay, change, change, cha-cha-cha, stay, change, change, cha-cha-cha, same thing. So I know this got a little bit confusing here, but the main ones is because I was trying to make sure you understood each part. But just to be clear here, we started with this one right here. We first converted that to this one right here, which we could then convert to this second one here, or third one really. And then finally, we converted that first one to this. So we end up with 4 different things here, because these 2 that we used in the middle were just to prove that we were right. So we don't need those because we already had them. So we're not going to go through that exact process every single time. I just, conceptually it's really important that you understand it. So again, we're adding, so we can simply change the order, and next one would be negative 5 plus 2. You can keep that negative 5 in parentheses if you want. It doesn't matter, because remember, we put those parentheses in to separate the addition sign from the negative sign. And now I'm going to take both of those and do the opposite and then the opposite again. So if I go straight from this one, and I start with my negative 5, do the opposite of addition, which is subtraction. The opposite of positive 2 is negative 2. There's my first one. And then my second one, and technically my third, I guess, but anyway, I keep my first one there, the 2, and then I do the opposite of addition, which is still subtraction, and the opposite of negative 5 is positive 5. So now I very simply have 1, 2, 3, 4 different expressions that are exactly the same. So this should be getting, quicker as we move along here. I'm going to switch the places. How many times am I going to forget to change that? 8 plus negative 6. You see how I put that negative 6 in parentheses? The only reason I did that was to separate the plus from the negative sign. So that's my first one. It's exactly the same. The next one, I'm going to do the opposite and then the opposite again. So I've got 8 minus positive 6. That wasn't really necessary. I could have just made it as 8 minus 6. They mean the same thing. But because I was doing the opposite and then the opposite again, I did want to put that in there. You could actually leave this one as another identical or equivalent expression to your first one. And then if I'm going to do the opposite and then the opposite again to this one, I would have 6. The opposite of addition is subtraction. The opposite of positive 8 is negative 8. So all of these are, again, equivalent. And here I am with my last one. I've got 2 negatives here. Again, just a number of different examples so you can see it different ways. Well, basically, the same process, they just look different, so it's important that you see each and every one of them. So for this last one, if I just switch their places, I've got negative 3 plus negative 5. The same, but switched around. If I do the opposite of the opposite, for this next one, I'm going to have negative 3. I'm actually going to take those parentheses out of there. It doesn't really matter if they're there in the beginning one. Negative 3 minus, the opposite of negative 5 is positive 5. Or I could just do negative 3 minus 5. They mean the same thing. And then I'm going to bring this one down here. Well, I'm not going to rewrite it, but I'm going to be referencing that one. So I would keep negative 5 in the beginning. Oh, that is a funny looking negative. Let me fix that. Negative 5. The opposite of plus is minus. The opposite of negative 3 is positive 3. So I could write it like this, or I could just do negative 5 minus 3. And they all mean the same thing. Now, converting equivalent expressions, and we've got these subtraction problems here. So it's really important that we understand that I can't subtract just by switching them. 9 minus 2 and 2 minus 9 are not the same thing. Because remember, if you think about this one, you have $9 and you spend 2. You've got $7 left over. This one, I have $2. I try to spend 9. I'm either going into debt by $7 or I just simply can't. I borrow money. Either way, this does not work. These are not the same. So if I use my same methodology as I used before, the opposite of the opposite, I'm going to have 9. I'm going to keep 9 the same. Minus, I'm going to change that to an addition problem. 9 plus, the opposite of 2 is negative 2. Now that I have this addition problem, though, I can switch them around. So I would have negative 2 plus 9. Those are the same. So just to be clear, in this case, the ones that I have, this is what I started with. This is the same, because it did the opposite of the opposite. And then once I had an addition problem, I could simply change the order and got to there. And then there is one more thing that I can do. Just wanted to pause there to show you that, because now that I have an addition problem, I can now do the opposite of the opposite here. So I could have negative 2. The opposite of addition is minus. The opposite of positive 9 is negative 9. So this 2 will give me the same equivalent expression. So that might have looked a little bit complicated, so let's do it again. It really, again, it's the same thing. Just using the opposite of the opposite, using all the same rules we used before, just applying them slightly differently. So I've got here for this one, I've got 3 minus negative 8. Can't just switch them around because it's a subtraction problem. But what I can do is the opposite of the opposite. So 3 minus negative 8, of course, remember, the opposite of the opposite is the same as stay, change, change, cha-cha-cha, all the same. So stay, change, change, cha-cha-cha. It's so fun to cha-cha-cha, isn't it? Anyway, I've got my plus plus, so that's just a plain old addition problem. I've got 3 plus 8. Both of them mean the same thing. You could write it either way. They mean exactly the same thing. And keep in mind, this is the opposite and then the opposite again. Different language, same thing. Far more fun to cha-cha-cha, though, isn't it? And we never get it wrong when we cha-cha-cha. Don't forget that. Now that it's an addition problem, we can switch them around. 3 plus 8 is the same as 8 plus 3. And now I can, again, do that opposite and then the opposite again. So that would be 8. Opposite of addition is subtraction. Opposite of positive 3 is negative 3. So I've got a string of equivalent expressions here. And same process, different looking numbers, different signed numbers in different places. So let's try this next one. I'm going to stay, change, change, cha-cha-cha, cha-cha-cha. Or I can think of it as doing the opposite and then the opposite again. So here I am, I've got stay, change, change, cha-cha-cha. There they are. They mean the same thing. Now that I've got an addition problem, I can switch the locations of each. So I would have negative 7 plus negative 1. They mean the same thing. I can, of course, then for both of these, or either one really, I can do the opposite and then the opposite again. So that would leave me with negative 7. The opposite of addition is subtraction. The opposite of a negative is a positive. So I would have negative 7 minus positive 1, or I could simply write this as negative 7 minus 1. Those also mean exactly the same thing. Okay, here we go again. This is fun. I love doing this. Okay, we've got negative 10 minus negative 2. We're going to stay, change, change, cha-cha-cha. Think of that as the opposite of the opposite, same thing. Then I've got an addition problem. I can now apply my commutative property and switch their places. So I would positive 2, I'm just going to write it like this though, and have 2 plus negative 10. They mean the same thing. And now I'm going to do the opposite of the opposite again. So I'm going to have 2. The opposite of addition is subtraction. The opposite of negative 10 is positive 10. I can have that positive sign in there or not. They mean the same thing. Moving right along, I'm going to move on to equations. Now this is where things are going to look a little bit different than they did before. So the first equation that we have, 10 plus 3 equals 13. Very straightforward. We should have a number of different ways that we can approach this. And this should look very familiar of things that you've done before. But just to refresh your memory and then see how we're going to apply it here to the rest of these equations, let's see what we can do. So the first one I've got here, the first thing I'm going to do is just like before when I had the expressions, I'm just going to switch this around. Instead of 10 plus 3, I'm going to make it say 3 plus 10. Still equal to 13. Now, recall when we solve equations, we always say, what's the opposite? So, when I look at this one and I want to know what the opposite is, or apply the opposite, I should say, I'll start with the plus 10 because that seems most obvious. The opposite of plus 10 is minus 10. I do that on both sides to keep it balanced. These two are going to cancel each other out. I'm going to be left with 3 on this side. And this time just don't do the math. I know it's tempting to do 13 minus 10, but they want us to keep those, the integers the same. So I would simply write 13 minus 10. And if you're doing this, kind of checking your math in your head, which you should be, you know that 13 take away 10 is in fact 3. So that's another one that we could do. I could go back to my first one. I'm going to rewrite it down here. So I would then therefore have 10 plus 3 equals 13. If I did that, I'm now going to look at the plus 3. What's the opposite of plus 3? You should know that's minus 3 on both sides. I know that these two right here would cancel. I'm going to be left with 10 equals 13 minus 3. Whoops, that's not right. 13 minus 3. That's right. We can actually further manipulate this and do the opposite of the opposite now that we've got something on the other side, or state change change, however you want to think about it. If I did state change change to this one right here, I would end up with 3 equals 13 plus negative 10. And for this one, I would end up with 10 equals 13 plus negative 3. So I know this kind of looks like it's all over the place here, so I'm going to go back and highlight all the ones that mean the same thing. So this was our original. We first changed it to this. Manipulating those things around, we changed it to this. We changed it to this one. And then the last two that we did were these two here and here. So a lot of different options here. I know that one looks like it's going to get in our way moving on to the next problem, but we'll just work right around it because we won't have to show, or we shouldn't have to show quite as much work as we go through this. So the first thing I'm going to do, because it's addition, I'm just going to switch them around. So this is going to say 2 plus, that's not it. I'm switching them around. So it's negative 5 equals, really, Michelle? Mrs. De Silva, whoever I am. Negative 5 plus 2 equals negative 3. Those, in fact, are the same. So now if I look at moving them around, doing the opposite for each of these, the first one I would have to consider is doing the opposite of plus 2. The opposite of plus 2 on both sides would be minus 2 on both sides. Minus 2 here and minus 2 here. These would cancel. I'm left with negative 5. Negative 5 equals negative 3 minus 2. If I take that one and do the opposite of the opposite, I would have negative 5 equals negative 3 plus negative 2. I'm going to go back to that original that I had up there. I'm just going to rewrite it here. Rewrite it in white so it looks the same. 2 plus negative 5 equals negative 3. This time, instead of moving the 2, I'm going to look at the 5. What's the opposite of negative 5? Well, you should know that the opposite of negative 5 is plus 5, or the other way I can look at this is minus negative 5. You're like, whoa, look at all those negatives. Minus negative 5. Think about it. If I'm adding negative 5, the true opposite of that is taking away negative 5. So these two would cancel each other out here. I'd be left with 2 equals negative 3 minus negative 5. Look at that. State change, change. Cha-cha-cha. Woohoo! 2 equals negative 3. Stay. Change, change. Cha-cha-cha. Leaves me with that. Which, had I done it the other way, I would have ended up with. So let's go back and highlight all of the answers here. This is my original. This is my first conversion. This is my second. Here's the third. We have the fourth and the fifth down here. All of these equivalent equations. Remember, different than expressions, but using the same basic principles. So now, this one looks different because we're dealing with an integer instead of just purely numbers. So now we just have to trust the methods. So this one, the first thing I would do, to be honest, the first thing I see when I see this is not the fact that it's addition, but I want to know what's the opposite of -6. The opposite of -6 is +6. If I were to do +6 on both sides, these would cancel. I end up with n equals 8 plus 6. Remember, it's an expression on that other side. We don't want to solve it at this point. We know that they're equivalent. The other thing that I can do, I can of course switch the places of my original addition, which would mean I'd have n plus -6 equals 8. I could then change that again, opposite, and then the opposite of to n plus, the opposite of plus is minus, the opposite of -6 is 6, so it would be n minus 6 equals 8. A lot of different ways that I can change this around. And then I can take this one here and look at that n alone, but then just switch them on the other side, so it would be n equals 6 plus 8. Lots of different ways to manipulate these and change them around. All fun though. This was my original. I changed it into this first. I changed it into this one, and this one, and this one. There are others here, but these are the basic ones that I want to make sure that you're familiar with and understand how to use. So the next one, I've got -5 plus y equals -9. The opposite of -5 is +5 or +5. They mean the same thing. That seems so weird, Mrs. De Silva. I know, we keep talking about it, right? -5 and +5, or -5 plus 5. They're opposites. They come 0, they cancel each other out. I'm left with y equals -9 plus 5. I can now switch those around if I want to. Y equals 5 plus -9. I could switch around my beginning ones. Actually, let's flip these. Let's do the opposite of this one. So y equals 5. The opposite of addition is subtraction. The opposite of -9 is +9. There's another one. If I go back to my original and switch their places, I would have y equals -5. Well, that's not what I wanted. Sorry. I would have y plus -5 equals -9. As you can see, I'm running out of room. I hope you're able to read that. And I can always change that to the opposite of the opposite. So I'd have y minus +5 or y minus 5 equals -9. They will all give us the same results. Our last page, this time we have all these subtraction problems. You should probably be able to turn off this video or pause this video and do all these problems yourself. We know we can't just switch the places of 5 minus 1 to get 4. So, but if we do change, cha-cha-cha, that changes things. So I'd have 5 sorry about that, 5 plus -1, change, cha-cha-cha, equals 4. That means the same thing. Now that it's addition, I can actually move them around. So it'd be -1 plus 5 equals 4. I can now move them to the other side, and I'm going to do this a little bit differently than I did in the last one, just to make sure you follow it along. So if I take this first one here, the first one I did, and I say, well, I just want to move this -1, and I know to move it, I need to do the opposite of it. So that would be 5 all alone equals 4 plus 1. I bet you knew that was true. If I The other way I could have thought about it was to leave the 5. I know I'm taking away -1, right? So it'd be 4 minus -1. Look at that. Stay, change, change. Cha-cha-cha. I end up with this one. They are the same. Let's try it with the one below it, which would be this one here. Instead of moving that -1, what's the opposite of +5? Well, I know that's take away 5. That would eliminate it on the first side, so I'd be left with -1 equals 4 minus 5. All equivalent equations. If I do my state change change here, I'd have -1 equals stay, change, change, cha-cha-cha. Never get over how fun that is. There we go. Got a whole bunch of equivalent equations here. Let's look at this next one. This next one should be a gimme. If you look right at that, stay, change, change, cha-cha-cha is right in front of us. Stay, change, change, cha-cha-cha. Then I get to get it right. 6 plus 4 equals 10. That is fun. That's good stuff. If I do the opposite of +4, I would subtract 4. I'm going to do that on both sides. Means it goes away here, so I have 6 equals 10 minus 4. If I use it with the 6 instead, I would have 4 equals 10 minus 6. I can change those subtraction problems into addition problems using my cha-cha-cha. I'm left with 6 equals 10 plus -4. Stay, change, change, cha-cha-cha. I do the same thing to the next one. 4 equals 10 plus -6. Stay, change, change, cha-cha-cha. Whew, I'm getting exhausted all these cha-cha-chaing. 2 more to go, though. Let's see what happens here. So I'm going to stay. I'm going to change right now. I'm going to stay, change, change, cha-cha-cha. That stays the same. I can switch their places now that it's an addition problem. -5 plus e equals -7. I can do their opposites. I leave e alone. I would have e equals, okay, so if I do it from either this one or this one, -5, -5, same thing. It's going to be plus side on the other side, +5 on the other side. So I'd have -7 plus 5. It's an addition problem on the other side. I can now switch those around. I've got e equals 5 plus -7. I can do the opposite and then the opposite with that. E equals 5 minus 7. Look at all that. I'm sure there's still even more ways to manipulate it, but we're going to stop there. That gives you a whole bunch of examples. Okay, c minus -2. Minus a minus. That's fun. Okay. Stay, change, change, cha-cha-cha. Stay. I always forget to revert back to my highlighter, or from my highlighter, I mean. Stay, change, change, cha-cha-cha. What? I didn't need that. Goodness gracious. Out of habit, I put it there because it was in parentheses above, but it doesn't need to stay in parentheses. That is unnecessary. So I did stay, change, change. I got my cha-cha-cha. Woohoo! These are addition problems. I can now just switch their places. 2 plus c equals -9. I can now do the opposite. I can do the opposite of this top one. Why don't I start there? The opposite of minus -2 is going to be plus -2. So that would leave me with c by itself equals -9 plus -2. If I did the opposite of, say, this one instead, the opposite of +2 is -2. So I would be c equals -9. What did I say? This one here, the opposite of +2 is -2. I could even, if I want to be fancy, manipulate this one. The opposite of plus c is minus c. We don't really do a whole lot of that quite yet. You'll be getting there, but not quite yet. But why not? So I would have 2 plus c. I'm going to do the opposite of plus c is minus c. That makes it go away. Equals negative 9 minus c. Oh, this is good stuff. If I did the opposite of the opposite there, let's do this. 2 equals negative 9, the opposite of minus is plus negative c. Oh, that'd be the opposite of c. This is fun, isn't it? Yeah. Well, I'm exhausted, and we have a whole lot of examples here. Hopefully you understand what happened here. If not, be sure and check in with me.